Welcome to When Do Limits Exist? So in the last video, we explained that a limit was a value of a function that you reached at a certain point. In this video, we're going to explain that sometimes limits don't exist within functions. So take a minute to work on the do now, and then restart this video when you're ready. So we know that the graph of j of x is going to be a linear function, and I sketched a picture of it right there. They want to know what the value of y is when x is equal to 1. So if you sub in 1, you're going to get that y is going to be 6, right? Now, if you plug in x is equal to -2, you should be getting -6. So we have the values, let's say, here and here. Now, we can say with limits that for the first one, the limit as x approaches 1 of the function j of x is equal to 6. Because if you look at the graph, as we're approaching 1 down here, the function is going to be approaching the value of 6 up here. We can also say that the limit as x approaches -2 of j of x is going to be equal to -6, because again, if you look at the function over here, as you come to -2, the graph actually hits -6. So last video, we looked at more towards the ends of functions as x approaches infinity or -infinity, but with limits, you could look within the middle of functions as well. It's kind of just plugging it in and evaluating it sometimes, like you have here. So there are several ways to find values of a function on the calculator. One is that you can look at a graph. Keep in mind that when you do this, it's not the best way to get the most specific answer because you don't have the actual numbers on the graph in your calculator. Another way of doing that is if you're looking at the graph and if you want a specific answer, what you can do is hit second. And if you look up top on your calculator, it's going to say calc. It's actually going to be right under the, or rather right above the trace button. And then from there, you're going to choose choice 1, which is value. So we're used to doing second trace intersect. You can do second trace choice 1 value, and what that means is you could plug in which value of x you want to look at in the equation. So if you plug in 5, it'll find the y value when x is equal to 5. The other way of using your calculator is go to the table and find the value from there. So how would we find the limit of a function without using the calculator? Well, I mean, that one's pretty easy. You're going to sub it in on your own. For example, if you didn't have the graph for the do now, you can just do, we had 4x plus 2. And if you wanted to find the limit, you could plug in what for the first one we had 1, so you could do 4 times 1 plus 2, that gives you 6, and you're done. Keep in mind you can't do that for all limits. Now, a limit exists if you travel along a function from the left side and from the right side towards some specific value of x. As long as that function meets in the middle, then that limit exists. So what that actually means is if you have a linear function like I do up top, let's say you want to find the limit at 3. We're going to look at the function as we come to 3 from the left, and as we go to x equals 3 as we come from the right. Now, when you actually get in the middle, you can see the left side and the right side are going to match up in the same place. Because they come to the exact same point, we can say that the limit exists. So, for example, if you were to have a different scenario, like a piecewise function, for example, from the left, we come down here. From the right, we're way up here. Because we don't come to a common point, the limit does not exist. Now, as you come from the right, we have special notation to say, are we looking from the left or are we looking from the right? Now, coming from the right is denoted with a plus sign. And coming from the left is denoted with a minus sign. Now, you know why that is because if you're coming from the right-hand side, that's from the positive x values, right? Now, if you're coming from the left-hand side, those are the negative x values. So that's where we get that from. Now, in order for a limit to exist, both the left and the right sides have to be equal. Now, if a graph does not break at a given x value, a limit exists there. What that means is if you have a continuous function and if you're looking at a point that is continuous, you're going to have a limit there. That would be example 1 up top. You had a linear function, the graph doesn't break at x equals 3, so the limit worked. Whereas in the side example, the second one, at the value we were looking at, there was a break in the function. There was a jump discontinuity, so the limit did not exist at that particular x value. The other note to keep in mind is that a limit still exists even if there is a hole. Now, that is a special case. We did talk about the last time how a limit doesn't mean you necessarily reach a point in the graph when we said that sometimes limits go on to infinity. It just gets very, very close to it, or it heads in that direction. So that's this type of case. If you were to have a function, and let's say the graph looked like this. That was your function. If you had a hole at, let's say, 2, and this value was 3. As you're coming from the left, you hit 3. As you come from the right, you still hit 3. So even though there is no point at x equals 2, we're going to say that the limit of this function as x approaches 2 is 3. So the limit exists here. Let's try several examples. So in this example, we have a graph that actually represents 2 separate functions. You have a piecewise graph going on, and if you want, you could graph both functions on your calculator. However, let's get to the point of what we wanted to talk about. Now, in mathematics, when a graph approaches 2 different values from the left and the right, we say that the limit does not exist because it can't be 2 different values. So check out what happens here. As you come from the left, we approach 1. As you come from the right, you approach 0. So here we're going to say the limit does not exist. Mainly because you can't be two different values. Like, what are we going to say? Is the answer 1 or is it 0? You can't choose both. Let's actually talk about the notation of this. So let's come from the left first. Now, as we're coming from the left, we're coming from the negative x values. So that means I'm going to write the limit as x approaches. We're looking at x equals 0 over here. But we're coming from the left, the negative x value. So I'm going to put a little minus. Now, the minus is kind of like a little exponent notation. It should be up top. Anyway, we have the limit as x approaches 0 from the left of f of x. And as we approach from the left, you get 1. And now we're going to go from the right. So we have the limit as x approaches 0 from the right, the positive x value side. So put a little plus in the top top right hand corner of f of x. As we come from the right, we go to 0. Now, because the negative limit and the positive limit are different, you're going to say that overall, the limit as x approaches 0, if you don't have a plus or minus, it means overall, of f of x does not exist. Now, what you can write for that is dne. Does not exist. Simple. Just keep in mind that the negative equals the left and the positive equals the right. Let's try a few more. So now let's look here. We're looking specifically as x approaches 0. So we're looking at your y-axis. Now, we're talking about from the left. As you come from the left side of the graph, that's over here, when you get to 0, we're approaching 2. As you come from the right side of the graph, I'm still going to get 2. Now, if you want to write that in limit notation, we have f of x, so I'm going to write the limit as x approaches 2 from the left-hand side, the green. So I'm going to put negative of f of x is equal to 2. Sorry, we're not approaching 2, we're approaching 0. Silly. 0 from the negative side. There we go. For the blue one, we're going to say the limit as x approaches 0 from the positive side, the right-hand side, of f of x. On the right, we still got 2. Now, in this case, because the negative and the positive matched, we got the same way from the same answer from both directions, we can say that yes, the limit exists because the left is equal to the right. And you can write that overall answer as the limit as x approaches 0 of f of x is equal to 2. Now for this one, we have used the graph at the left to answer the following questions. What value does y approach as x approaches 1 from the left? So we're looking here, and we have that y approaches 1. Now they're asking what value does y approach as x approaches 1 from the right. And we approach 2. So does the limit exist or not? And we're going to say no, because the left does not equal the right. If you want to really fully write this out, you would say that the left-hand limit does not equal the right-hand limit. Now, if you want to write this in proper limit notation, you're going to say that the limit of f of x as x approaches 1 from the negative, that means from the left, is equal to 1. The limit of f of x as x approaches 1 from the right, the positive side, is going to be 2. Because the two values are different, your total overall answer is going to be the limit as x approaches 1 in general of f of x does not exist. Now, you don't have this in your worksheet, but we figured it would be a good last example for you. I have the equation that I have up top, which is 1 divided by x plus 2 times x minus 2, and this is going to be the graph of it. Let's take a look at what happens when you're looking at the limit as x approaches 4. So we're going to start with this one here. We have as x approaches 4 from the negative side, so from the left, and this is 4, by the way. Now, as you come from the left, you're heading down towards negative infinity. Now, as you're approaching this function at x equals 4 from the right-hand side, positives, you are going up towards positive infinity. Now, I know that that kind of looks like it's a decreasing function because you're used to reading it from left to right, but keep in mind that we are coming from the right-hand side. So you're moving from the right, and as you go towards 4, your graph is going up. Now, if you were to look at the limit overall at 4, first of all, you should be able to see that they don't match, right? One's going up and one's going down. Or you can look at your previous two answers. One is negative infinity, one is positive infinity. So overall, your limit does not exist. So keep in mind with limits that if you have a little negative exponent, you're coming from the left-hand side. If you have a little positive exponent, you're coming from the right-hand side. And in order for a limit to exist, you got to make sure that the left-hand side and the right-hand side are equal. Otherwise, you're going to write DNE for that limit does not exist. And that's all for this video.